I'm Michael West, Technical Product Manager with VMware. vSphere with Kubernetes exposes a new set of services that developers can consume through the Kubernetes API. The VMware Tanzu Kubernetes Grid service for vSphere allows developers to lifecycle manage Kubernetes clusters on demand. The network service enables integrated load balancing, ingress, and network policy for developers' Kubernetes clusters. The storage service integrates vSphere cloud-native storage into Kubernetes to provide stateful application support with persistent volumes backed by vSphere volumes. The vSphere pod service takes advantage of the other services to deliver pods natively on ESXi. The primary place that customers will run pods is in the upstream aligned, fully conformant clusters deployed through the Tanzu Kubernetes Grid service. The pod service complements the TKG service for specific use cases where the application components need the security and performance isolation of a VM in a pod form factor. And finally, vSphere with Kubernetes has a native registry service that can be used to deploy container images as Kubernetes pods. Application-centric management means that policy has been attached to namespaces that contain developers' applications. Operations teams now have a holistic view of an application by managing the namespace that contains all of the application objects. Okay, let's see how this works. This is a simple declarative YAML specification for a Kubernetes cluster. The Kubernetes cluster kind is defined through a set of custom resources that are part of the VMware Tanzu Kubernetes Grid service for vSphere. Applying that YAML specification creates your Tanzu Kubernetes cluster. The kubectl get command shows we created a 2-worker node cluster. The network service works with the Tanzu Kubernetes Grid service for vSphere to provision load balancer-based access to the Tanzu Kubernetes cluster. The storage service provisions the cluster nodes based on the storage classes defined in the specification. Developers can use the registry service to stage container images in the built-in Harbor registry for use by the vSphere pod service to deploy pods directly on ESXi. With VMware Cloud Foundation services, infrastructure is managed as code, and developers can take advantage of the entire Kubernetes ecosystem, including source code repositories like Git. As developers leverage VMware Cloud Foundation services, the operations teams have a real-time view of the activity in vCenter. Tanzu Kubernetes clusters and pods running directly on ESXi are visible in the inventory view. As the developer deploys their application, the vSphere pod service provisions the pods directly on ESXi, and the network service creates the ingress to the application through a native load balancer. In this example, we create a persistent volume claim, which causes a vSphere volume to be created and bound to the claim. We then deploy a pod that mounts that volume. Finally, we create a deployment of web server pods to provide our application's user interface. Access to the UI is through a load balancer provided by our network service. Keep in mind that TKG clusters are the primary way that developers will deploy their applications. And TKG clusters also make use of the network and storage services. The pod service gives the developer the option to deploy pods on TKG clusters or, for specific use cases, directly on ESXi. They are complementary services. Each of the Kubernetes objects has its own inventory item. Pods are running as first-level objects directly on ESXi. They have their own summary and detail screens. Tanzu Kubernetes clusters have an inventory object with details on the cluster and individual virtual machine items for the VMs that make up the cluster nodes. All of these are layered under the namespace they were created in. Namespaces provide an abstraction that holds both Kubernetes and vCenter policy. Through integration with vSphere single sign-on, operations teams assign users or groups access to a namespace. Storage policies are also assigned. This assignment causes storage classes to be created in both the supervisor cluster and in your Tanzu Kubernetes clusters for use by the storage service. CPU, memory, and storage limits can be assigned. Namespaces are backed by vSphere resource pools that enforce the CPU and memory limits through DRS. Storage limits are pushed into the Kubernetes clusters and are enforced through resource quotas. The platform promotes collaboration between developers and operations teams. vCenter provides deep visibility into all of the objects created by the developers. Compute objects like pods, deployments, and Kubernetes clusters, storage objects like persistent volume claims, network objects like load balancers, and even Kubernetes events are surfaced to the operations team. All of this in the context of the namespace to align infrastructure objects into application-centric management.